Thank you, James. My intention here is to try and inform everybody about the effect of Approved Document B changes after the fallout from the terrible disaster at Grenfell. So this is very much focused on flat roofing. To start with Approved Document B, I'm going to be talking about this for England, so we're specific for England here. This slide is just showing when it was actually brought into being. There has been a couple of changes this year, but they haven't affected the topics that I'm covering here, specifically on flat roofing. So focus on Approved Document B, which affects England. The Approved Document B comes in two volumes, Volume 1 and Volume 2. A lot of my references are to do with Volume 2. Each of them is at least about 200 pages. And what I've tried to do is do all that hard reading for you and come out with what the main topics to do with flat roofing are and where they are in these different sections. So I'm going to give you a quick run through the document just to find out where it's referenced, and then we'll get a little bit more into the detail. So if we move into the first part, B1, which is means of warning and escape. The main area that flat roofing is mentioned here really is that if you do have a flat roof and it has a means of escape across the top of it, and that means a prescribed means of escape, not just a roof that possibly could be escaped over, then there is a special provision required for the deck and the substrate, which will affect the performance of the deck materials and perhaps the ceiling. Also then talking about ceilings is then we have B2, and the main thing that B2 covers is internal spread with regard to linings. And the main relevant area here from flat roof point of view is mainly roof lights, which is a reasonable chunk about roof lights there, but otherwise also if it is that there is a exposed deck. So if it was you had no ceiling and you looked up and all you could see was the deck, then you would need to take special precaution there for what the deck is. We then move on to B3, which is internal fire spread structure. Now, interestingly here, it makes it clear that for the purposes of this, a flat roof is not classed as an element of structure. So most of B3, therefore, is not relevant unless it is that the roof is classed as a floor. So why might a roof be classed as a floor? Well, if it was, say, a roof terrace or maybe a car park deck or something like that. So there you would need to take account of some of the cautions in B3. But there is one other area of B3 which has a lot of misunderstanding, and that's to do with where a junction of a compartment wall with the underside of a roof. And this is an area where it is very complicated in the document. MHCLG totally acknowledge this. They're trying to reword it without changing the fundamental meaning. And I've been helping in that process. But what I can say or simplify it is, if it is that the deck of your flat roof is non-combustible, i.e. concrete or steel, or it's a timber deck that is less than 15 meters high, in the purpose groups of residential, office or assembly and recreation, then provided as your roof system achieves B roof T4, which most flat roofs do, then you shouldn't have to do any extra precaution. So if it's above 15 meters and not in those purpose groups with a plywood deck, you would have to make extra precautions. And that assumes that you've got a seal to the underside of the deck with something like cement mortar. Of course, the other way of avoiding all of that is if the wall carries on through the deck above, then that's another way of dealing with it. Then we come to the main area of Approved Document B that has affected flat roofs for years and years, which is B4. And that is simply put, the roof of the building should adequately resist the spread of fire over the roof and from one building to another, having regard to the use and position of the building. That last part being very important about how far away the next nearest building might be, depending on what your roof materials are. So we then come into the new bit, which you could call the ban, which is Regulation 7. And Regulation 7.2, on one hand, sort of like takes away, it basically says that materials need to be non-combustible, A2 or A1, when they're in an external wall or a specified attachment. But then it gives back in 7.3 stating, but the exclusions to that, and I've listed the ones relevant to roofing here, flat roofing specifically, any part of a roof that's part in connection with the external wall, or if it's a membrane, or if it's a thermal break material. Now, we're going to talk about these in a bit more detail as we go on. So there are 3 relevant exclusions. And just so we need to define a relevant building, this is only applicable to relevant buildings, which at the minute is at least 18 meters high above ground level, that may contain dwelling, institution, or room for residential purposes. And just to help with the explanation a little bit further, regulation helps on external wall, which states that it's anything located within forming part of the wall. So it's not just the surface, it could be what's inside the wall. And also any part of a roof pitched at greater than 70 degrees. A roof ceases to be a roof above 70 degrees, it's then a wall. So there is an exception if it's only used for maintenance. And then also a specified attachment is, in this case, it's a balcony attached to an external wall. Another type of specified attachment could be, say, a PV panel. Now, just to put all of this into perspective, the ban started to bring in the need to look at the reaction of fire to fire of specific individual products. Now, always in terms of flat roofing standards, we've always talked about system buildup. So this is quite new and quite alien. And as you can see from this table, this is just a rough overview, just to give you an idea of some of the categories typical materials might be that you might use in roofs. You'll see that nearly all the common materials you use in flat roofing and have done for the last 30 or 50 years are in reaction to fire E, which could be classed as one of the worst classes. But when they are put together as a system, then that maybe changes the performance of the roof. So we need to just keep that in mind. So we come first to one of the issues we've come across in interpretation of approved document B. Regulation 7 states that you can exclude membranes. Yet it's commonly thrown at me as the fact, yes, but in the approved document, it says that membranes used as part of an external wall above ground level should achieve a minimum of class B. But if you read that sentence very carefully, it doesn't mention specified attachments anywhere. It quite specifically says external wall. And so specified attachments is not included in this. So it means a specified attachment could have a membrane on it with a reaction to fire worse than B. And as I've just demonstrated in the previous slide, that's typically going to be E. As a general point, but a secondary point, the flat roofing industry does not supply flat roofing membranes that achieve anywhere near B. There may be membranes you've come across that might achieve B, but they're not used or suitable to be sealed and used as flat roofing. So that is now that's a common misunderstanding in there. Another point was the fact that you could have a flat roofing membrane on the horizontal, but you need to dress it up the walls to make it waterproof. And so again, there was a lot of confusion about that. And a year ago, the MHCLG were good enough to write to the industry just to clarify that, yes, they totally accepted that flashing to a wall was acceptable. And again, I'll show you maybe the extent of that in some diagrams to come. So basically, we would follow normal flat roofing practice. So here we have a typical detail of an inverted roof first. I'll show you a warm roof next. And this is showing a typical detail where I'm just trying to emphasize what I mean by a thermal break. So for flat roofing, there is within Part L reference to accredited details, and it talks about thermal breaks. So we see here for a parapet, the insulation in the wall actually continues to the top of the wall there of the parapet. But there is this flanking heat loss through that internal leaf. And therefore you need a little bit of insulation on the upstand there. And that's described as being a minimum of 300 mil from the deck upwards. But we always need, as roofing practice, at least 150 millimeters of waterproofing above the finished roof level. And as you can see in this diagram, the finished roof level is the top of the paving, not where the waterproofing or the water flow reducing layer is. And that thermal break is usually a nominal thickness of insulation, not usually more than 60 mil thick. We can see the same detail here with a warm roof where the waterproofing is in top of the insulation. So you can see the 150 mil from the top there, but still we have the thickness of insulation of 300 mil from the deck. Now with increasing thicknesses of insulation, sometimes the main body insulation there can be well towards that 300 mil. So just for clarification here, this will just help in terms of where you can use combustible and non-combustible insulants for the thermal break. There is a general exclusion for thermal breaks, which would mean you could use combustible insulants, but as general guidance, we suggest that for abutments not higher than 150 millimeters, you could use either material. If the insulation is taken above 150 millimeters and perhaps is against a habited wall, then the material there should be a non-combustible insulant, which is typically going to therefore be a cellular glass or a mineral wool. And what is commonly done with technology of waterproofing these days, it's quite easy to take waterproofing higher up a wall, and so we commonly encapsulate parapets. The upstand insulation used against the parapet really only needs to go at the 150 mil above the finished roof level. As I demonstrated in the first diagram, usually there's some insulation in the parapet anyway, so you don't need to extend the thermal break all the way up. But you can extend the waterproofing to typically about 1.1 meters high. And in this instance, it would be, again, a non-combustible insulant. I've just added a little note at the bottom there. Just in working with the NHBC, we came up with this sort of general guidance. They acknowledge that a parapet wall, the inside face, is covered by approved document B, but they take the pragmatic view that up to 1.1 meters high, then they don't see that as a problem. I think if you went above that, you would certainly need to seek advice. We then get into the definitions of balconies, and there was a lot of confusion about balconies because most people thought about the left-hand diagram to start with, but hadn't perhaps thought immediately about inset balconies. And so we needed help with the clarification of what was what with a balcony or a terrace. Now, we've been helped by BS 8579. It was launched just at late summer, and the committee working on that were very aware that they needed to tighten up some of the descriptions of balconies and terraces to help the interpretation of approved document B, and also provide some diagrams that helped with what was a balcony and what was a terrace. So you can see here the areas that are marked in the sort of orangey color there are areas that would be classed as a terrace and therefore a roof. The next slide will explain that. So before, we never really had to determine between a balcony and a terrace. They were interchangeable words, but from a fire point of view now, we have to be very specific about what we mean. So for a balcony, it's for external amenity, but an important bit is it's not necessarily above it's not above habited area, and so it's for the purposes of fire, it's not a roof. Whereas for a terrace, that's quite specifically above a habited area, and therefore would be treated just like a roof has always been treated, following the normal requirements for a roof. So as you can see there, terrace is a roof for the purpose of fire and waterproofing. And remembering it can also be classed as a floor. Now, just to give an overview for what normal practice has been for many, many years for flat roofing, is in relation to where boundaries are, which is the requirement of B4. For flat roofing manufacturers, we always look to achieve B roof T4 or an old money AC rating. And it would be rare that you would ever see a manufacturer going to market probably with a C roof for D or E. It doesn't mean they're failed. It just means that you have to start thinking about how close your nearest building is. Whereas if you go with B roof T4, you don't have to worry about how close your next building is. So that's a typical unrestricted rating. To avoid the hundreds, if not thousands, of permutations of fire tests that are necessary for the manufacturers, we can't possibly do them all. There are a few that we don't need to do because there has been a European Commission decision on a number of build-ups. And the classic area is where you have ballasted roofs, whether they're warm roof or inverted. If you have at least 50 mil of stones, or you have 30 mil of screed, or you have a minimum of 40 mil of stone or concrete slabs, they're deemed to satisfy. So there's classification without further testing because they're non-combustible and therefore you don't need to test the roof system below that. However, there is one grey area there, which is the fact that when it talks about paving, it doesn't mention in that directive anything about whether there's any gaps in the joint or any pedestals or the like, which we typically do in the UK, maybe less so in Europe. So NHBC, again, working with them as thought leaders in this area, we have come up with some pragmatic guidance here, which is if it is the paving slabs are raised on pedestals, provided it is there's a water flow reducing layer, if it's an inverted roof, and the void is not greater than 30 millimeters, then they would feel that that was fine without further testing. If there was any doubt, maybe a larger void, or there was a prescribed fire route across the roof, then they would suggest that there should be a granular fill under those specific areas. Or finally, if there was a specific fire test that had been done, then of course, then that would be acceptable as well. But it's with all the many tests that we need to do, it's one test that should be a bit more of a no-brainer in terms of passing with typically a concrete deck and typically non-combustibles on top. Then we move on to requirements for green roofs. And there is only really one guidance that's ever been published in the UK, which the DCLG some years back made, where they did a lot of research and testing. And the Green Roof Organisation's guidance is based on that. And I've short formed the main points into a few bullet points that we can see here. So the first point is if you have a growing medium, it should be certified for use in a green roof, and it should have organic content less than 20%, or the organic content should be less than 20%, and it should be peat free. The other point then is that green roofs should have fire breaks around them. So around the perimeter, there should be at least 50 mil of stones, round pebbles or paving. And wherever there is, and that width is typically 300 mil, but if it is that there are penetrations where they could be openable, in other words, a fire potentially could get into the building, so I'd say an openable roof light, then you would put a 500 mil wide border around those areas. And if it's a particularly large area, then you would put a 1 meter fire break every 40 meters across the roof. A very important point is if it is that you're going for maybe some of the wildflower type green roofs where they have a lot of thatch that is left from after the summer, it's very important that they're properly maintained. Now, any green roof manufacturer would always advocate good maintenance, but unfortunately it's a thing that the client often negates to do. But there's a double reason for doing it now. So then we come on to the testing. As I said, there are hundreds, if not thousands, of permutations, and the manufacturers need to do as many as they reasonably can. And there are actually only 2 test facilities in the world that can fully do this, one in Watford, BRE, and one in Ghent in Belgium, which is Warrington. And so there is often quite a long waiting list, so it's not always easy to get a fire test done very quickly and easily. So as manufacturers, we all have been working on improving our width and breadth of fire testing. And as I've said, we would be typically looking to achieve B-Roof T4 as a pass result. And in the areas where it is deemed classification without further testing, it's not typical that we would test that. Now, one important point is if you come across a test certificate, we will typically test on an OSB or plywood deck. And the reason for that is because it's deemed the worst case scenario. So there's no point in testing on a steel deck or a concrete deck, because then you would still have to test on a timber deck, because the timber deck is classed as worst case. So that is just to explain why it is that you might commonly come across that a fire test is on a timber deck. So from a Bauder point of view, we test all our common systems. I will readily acknowledge there are many tests that we can't possibly do because there's just so many of them. We have an ongoing program of testing all the time. Our agreement certificates are usually a good typical area of where you'd find test certificates. But because agreement certificates are renewed every 3 years, typically there could be new ones in between. So you should always ask the manufacturer if it is that you don't see the test in, for instance, their test certificate. So as I say, we're continually updating our testing. So if anybody wants any more detailed information, there is a address you can go to there to download more information, and there is a specific document, a white paper specific on the topic I've been talking about. So James, that's the last slide.
Thank you very much, Nigel. We have a couple of questions. I'm going to allow us just to go slightly into the break so we can get the questions asked. First question, do you have any thoughts on green roofs from a fire point of view?
Yeah, so as I've said, that one slide there is that the main guidance is based on some old government sponsored testing, and GROW have followed that. So that's the main written guidance. And the key thing really is there are a few of the sedum blanket types where you can actually fire test them. So for instance, in the Bauder range, we have some there that we do achieve B-Roof T4. Some of them are very difficult to test. But you've got to realize that often there's a thick growing medium that's at least 50 mil thick, which would be the equivalent of the 50 mil thick of the stones and ballast. So, and it's typically going to be on a concrete deck. So it's the initial fire spread that somebody might be worried about probably would be a very quick flash across, especially if it's tinder dry. So hopefully that answers the question.
Okay, we've got another one here. Just says, my understanding was that green roofs would be banned under the building regulations. If the roof covers more than one demised property, is this your understanding as well?
No, it's definitely not, as there's a thriving industry of green roofing, and it hasn't diminished because of the changes to Approved Document B. The industry is very much in support of clarification on what needs to be done for correct compliance with Approved Document B. And obviously the correct use of fire breaks. So if it's across different properties, then there may be reason to separate, and so the correct use of fire breaks there would be there. But no, absolutely, green roofs are still very much being used, especially in the London metropolis.
Next one, a lot of work has clearly gone forward to develop this new legislation after Grenfell. However, with regards to existing flat roofs, are there any areas that landlords should be checking during PPM?
existing landlords, so we're talking about existing roofs, I take it. So is the I mean, in the end, is the fact that the regulations for flat roofing, and that was one of my earlier points, is the flat roofing guidance really hasn't changed. The approved document B brought in some unintended consequences because it was intended to exclude roofs, but unfortunately a lot of the points I've had to raise there are where it's maybe brought it in, or people thought it had been brought in, but they are exempt from. And the way we've done flat roofs has been the same more or less for many, many years. Probably the main difference from a fire point of view is we don't tend to put chippings on a roof the way we did, say, 15, 20 years ago. I haven't seen a chipped roof for a long time, as in done newly. So, but maintaining chippings on a roof, if they had chippings, would be keeping up with your fire performance. But typically a roof of old would have still met the fire requirements of today.
Okay, now there are lots of opinions on interpretation of approved document B in this area. What is being done to address them?
Yeah, well, so one of the big things here is that in consultation with MHCLG, there were a few areas where we pointed out that maybe they'd confused a bit, and they said, yes, but it's not for us to be prescriptive in some of those areas. It's for you guys as the industry. So in this instance, the flat roofing industry. So the flat roofing industry, under the guise of LRWA, SPRA, NFRC, are actually finalizing a document which will hopefully succinctly put some of these misconceptions or unintended consequences together. There's been guidance on fire performance on roofs in those various parts for always. So that guidance is still there, but there will be some new guidance that will be coming forward, which, as I said, MHCLG have very much encouraged us to do. And as you've heard a few times in my presentation, we've had quite close consultation with the likes of NHBC to make sure that we're all singing from the same song sheet, because then we don't have people keep saying it's confusing, I disagree. We try to get some consensus, and that comes from a common point.
Okay. What is the insurer's position on combustible materials in a flat roof?
Okay, well, so one of the advantages, if I can put it that way, of the recent period, COVID, etc., is the ability to talk to a lot more people that you might not have normally got to speak to. And the insurance industry have been more contactable, and they've wanted to express their concerns about fire, say, on roofs. And their biggest concern is typically what the deck's made of. So as we saw on that little slide about the compartment walls, that non-combustible decks aren't seen as so much of a problem. So it tends to be timber decks that the insurance industry will look more closely at, and then they will tend to then look more closely at what the insulation type might be. But hopefully what I was also demonstrating there is even combustible insulants meet the current standards for the building regulations. Now, an insurer would say, yes, but we're concerned about buildings as well as lives. And so, but many of them will accept combustible insulations as long as it achieves B roof T4. It mainly tends to be, if it's a timber deck, that they would probably then insist that the insulation was also non-combustible.